What if the world's most powerful investment is a lie? It's a question that has captivated some of the most brilliant minds on the planet, from Elon Musk to Neil deGrasse Tyson. The idea is simple, but the implications are staggering. What if our entire reality, the one you see, hear, and feel, is nothing more than a hyper-realistic computer program? According to philosopher Nick Bostrom's influential paper, there's a staggering statistical probability that our universe is, in fact, a simulation run by an advanced or post-human civilization. 1. The central problem. The argument is elegantly simple. It rests on a powerful logical dilemma, a trilemma. Bostrom states that at least one of these three propositions must be true. Point 8 first. It is overwhelmingly likely that human civilization will go extinct before reaching a post-human stage with the technology to run simulations. Second, it is overwhelmingly likely that any post-human civilization would have no interest in running ancestor simulations of their own evolutionary history. Or finally, it is almost certain that we are already living in a computer simulation. Given the exponential growth of our own computing power, this third option seems almost inevitable. Our ability to create digital worlds is accelerating at an unimaginable rate. So, if a civilization could create billions of ancestor simulations, and we exist in just one of them, the laws of probability dictate that we are more likely to be a simulated mind than an original, biological one. A simple logical puzzle with a terrifying conclusion. But if the answer is so clear, why isn't everyone talking about it? 2. The common proof. For years, people have searched for glitches in the code for evidence that our world is a fabrication. The most popular theories come from the bizarre world of quantum physics. One common claim is that the double-slit experiment, where particles behave differently when observed, is a computational, power-saving feature. The thinking goes, the simulation only renders the reality when a conscious observer is looking, just like a video game. Another popular theory suggests that the speed of light and time dilation near black holes are a form of lag, a processor limit of the simulation. These analogies are powerful and seem to explain the universe's strange behavior, but they are based on a profound misunderstanding of both physics and computation. 3. The core rebuttal. The problem with these glitches is that they are themselves a simplified view of an infinitely complex reality. Real physicists argue that if our world were a computer simulation, its computational limits would be astronomically large and utterly incompatible with what we know about physics. Critics point to two major problems. First, the laws of physics are far from simple. They are highly dynamical and chaotic, meaning even a tiny error would grow exponentially, making it impossible for a computer with finite precision to model our universe over the long term. Point 12, there is no evidence of the pixelation or blurring that would occur if the universe were a finite, computationally limited simulation. Second, the very idea of a simulated reality is predicated on an endless chain of nested simulations. But a simulation can never be more complex than its host. This overhead means the number of possible simulation layers is actually very finite, undermining the central probabilistic argument entirely. This leads to a fascinating paradox. The simulation hypothesis is often defended by citing Occam's razor, the principle that the simplest explanation is usually the best. But the hypothesis, which requires a new and even more complex base reality to run our existing, incredibly complex universe, is arguably a less simple explanation than the alternative. 4. The ultimate test. But what if we're looking for the wrong kind of glitch? What if a truly advanced simulation doesn't operate like a clunky video game? What if the very oddities we call glitches are actually sophisticated features? Real physicists are now searching for proof not in glitches, but in hard-coded limitations. For example, they are looking for a sudden drop-off in the energy of cosmic rays, which could suggest a fundamental energy limit imposed by the simulation's finite resources. But perhaps the most mind-bending perspective comes from looking at the very laws of quantum mechanics itself. specifically the idea of quantum entanglement. The popular narrative frames entanglement, where particles share an instantaneous connection across vast distances, as a bug that saves processing power. But modern research with quantum computers suggests the opposite. Entanglement isn't a problem to be solved, it's a computational asset. Studies have shown that a quantum simulation becomes more efficient and less prone to error the more entangled it becomes. The glitch is not a flaw in the system. It is the fundamental mechanism that makes the simulation possible in the first place. This brings us to the grand, final paradox. Even if we found a piece of definitive evidence, a glitch or a cosmic limit, how would we truly know it wasn't just a new, fundamental law of physics we had yet to discover? The simulation hypothesis is an argument built on what we don't know. Its true power is not in providing a definitive answer, but in forcing us to question everything. It asks us to perform the ultimate due diligence on our reality itself. Perhaps the simulation hypothesis isn't a theory to be proven, but the ultimate question we must ask ourselves. What do you think the purpose of a universe-scale simulation would be? To study consciousness? To model a financial system? Or is it a digital sandbox for a childlike deity? Tell us your hypothesis in the comments below. And if this kind of intellectual exploration is something you value, please like this video, subscribe to the channel, and turn on notifications to join our community of thinkers.